And when we multiply those three 5s together, we get 125, so that's the equivalent of 1 over 125. B, we're going to simplify negative 10 to the negative third. Now, what's different about this one, compared to the questions we had earlier in number 1, is the base, the big number, the 10, is actually negative. So we're going to have to factor that into what we're doing here, but it doesn't change the initial setup. We're still going to write this as a fraction, negative 10 to the negative third, over 1. And then we're going to take this piece and flip it to the other side of the fraction, which is going to make it positive. The exponent, not the base. The negative 10 isn't changing, it just makes the exponent go positive. The top was left vacant there, so in this case, that's going to have to be changed into a 1. So this is 1 over 1 times 10 to the negative third, or we can simplify that using the same logic we used in 2a, and write 1 over negative 10 to the third. So we're going to take negative 10 and multiply it by itself 3 times now to come up with a solution. Negative 10 times negative 10 is going to make positive 100, and then I'm going to multiply it by negative 10 again, and that's going to make negative 1,000. So this is 1 over negative 1,000, or negative 0.001 when we divide it out. Obviously, you've kind of guessed that the negative exponent is a problem for us in the solving step because we really can't do anything with it until we do that flip and make it positive part. But the other thing is, mathematicians generally don't like to see a negative exponent written in an answer unless it's an absolute must. If it was something that was very microscopically small in scientific notation type idea, otherwise we generally avoid the negative exponent altogether. When it pops up, we take the time to flip it to that other side of the fraction and make it positive. And we'll keep that as a general principle as we move forward here in Chapter 4. So, here's our order of operations question. Continuing to practice with that negative exponent. Also practicing for the first time in this section with the concept of a zero exponent. What's important about the zero exponent, it's actually very easy, is that anything to the 0th power must equal 1. It doesn't matter what it is. If it's to the 0th power, it equals 1. So when I take this negative 2 to the 0th power here at the end of this question that I'm about to solve, as you can see when we go down here, that changes into 1. It doesn't matter what it is, whether it's negative 3 or 7 or 908, it's always going to go to 1. So let's start solving here. 5 minus, and then parentheses, 6 minus 4, close parentheses being raised to the negative 3rd power, plus negative 2 to the 0. So a couple instances of parentheses to tackle first here. But again, we already know this 1 at the end is going to become 1, so we're not going to worry too much about that. We are going to spend some time working on this 6 minus 4 to the negative 3rd part. 6 minus 4 inside the parentheses is going to change into 2, and that's going to go to the negative 3rd power. Well, we already know what to do here because it's the same procedure we've been using. We're going to go ahead and write that as a fraction, and then take that part with the negative exponent and flip it to the other side of the fraction, and that's going to make it positive. It's also going to leave the top totally vacant, so that's going to fill that in with a 1. One of the other things you might be wondering is, what if the negative part was in the bottom of the fraction? Do I do the same thing? Yes, you absolutely do. If the negative were to be in a fraction already in the denominator, the bottom, when you flip it up then into the numerator, that would also make it positive. It's the act of flipping it over to the other side that has the effect of making it positive. So 2 to the 3rd, that's going to be 2 times 2 times 2, or 2 times 2 being 4, times 2 again is 8. So this is 1 over 1 times 8, or 1/8, as you can see there. So we've got 5 minus an 1/8 plus 1. Well, 5 minus an 1/8 is 4 and 7/8, plus 1 is 5 and 7/8. All right, let's go ahead and take a look at the check it out examples here. Number 1, they're asking me to simplify 10 to the negative 8. We see the answer, but what we don't see is how they got there. So again, what we want to do is write this as a fraction, 10 to the negative 8th over 1. And then we're going to take and flip that to the other side of the fraction. And again, that's going to have the effect of making this go positive. So when I flip that down, the top is vacant, so that's going to fill in the 1. So this is 1 times 10 to the 8th. Well, 10 to the 8th, that's 10 times 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 10. And as you know, when we multiply tens together in that way, the exponent equals the number of zeros we have. 10 to the second, for instance, being 100. The exponent is 2 zeros on 100. So this has 8 zeros on it. As you can see, this is 100 million. So this is 1 over 1 times 100 million. And of course, that's just going to change it to 100 million. So this is 1 over 100 million, or 0.00000001. Negative 4 to the negative 6, again, same thing. I'm going to write that as a fraction, and then I'm going to flip that to the other side of the fraction, which is going to have the effect of making that positive. The top will be left vacant, so that's going to change into a 1. And that's negative 4 being raised to the 6th power now. So I've got to take negative 4 and multiply it by itself 6 times. Well, 4 times 4, that's going to make 16, and since they were two negatives to start, negative times a negative, that's going to change into a positive. Times negative 4 again for the third time gets me to negative 64. Times negative 4 again for the fourth time gets me to positive 256. Times negative 4 again gets me to negative 1,024. Times negative 4 for the sixth and final time gets me to 4,096, which you kind of expected since the answer was pre-printed on the screen. So this is 1 over 1 times 4,096, or 1 over 4,096.